Hello everyone and welcome to this Midas Civil Webinar. My name is Norbert Kovac and I'm a technical support engineer at Midas. Today's webinar will be on two-span composite prestressed concrete integral bridge design to Eurocode. A few things about GoToWebinar. We have already confirmed that you can hear me. So if you can't see the screen, this might be because this is minimized. So before the session starts, you might want to maximize this. And if the screen goes blank, this might be because the screensaver has kicked in. So you can turn this off now. Also, if you would like to hide the dialog box, you can just click on the red arrow. And if you have any questions, you can put these into the chat box and I will answer them as soon as possible. So the contents of the webinar, today I'm going to talk about Midas. I will be doing modeling in Midas Civil, along with the application of loads and boundary conditions, analysis, results extraction, and design. So a few things about Midas. Midas is the largest engineering software development company in the structural and geotechnical engineering disciplines. Midas Civil has been also used for all the major long-span bridges as well as for conventional ones. On the left-hand side, you can see a partial list of some of our clients. And on the right hand side you can see some of the projects for which Midas has been used, such as Burj Khalifa, Beijing Olympic Stadium and Rusky Island Bridge. So about integral bridges, these are using concrete beams which are pre-tensioned with high tensile strength strands, and concrete beams and the deck slab act as a composite. The advantages of these kind of bridges are that these are ideal for road, rail and footbridges. Using Midas Civil, users can create both new designs as well as carry out the assessment of already existing ones. So this is the model I'm going to be creating today. As you can see, it has two spans. Both spans are 30 meters long. The width of these are 20 meters. The center-to-center distance between the girders are 1 meter and their depth is 1.5 meters. The girders are integrally connected to the abutment. The abutments are 3 meters deep and the piles are 10 meters. Okay, so let me swap to the software now. As you can see, this is the Midas Civil interface. At the top we have the ribbon menu. This is composed of a variety of tabs. All these tabs are positioned in a logical manner in order to aid the user's workflow. On the left hand side you can see the tree menu, and also if I right click on the black ribbon, I can activate the second tree menu, and I will shortly explain why this is very useful. So moving back to the first tree menu, as you can, in the works tree, you can see all the work that you have done so far. So if you define the loadings, boundary conditions, anything that you define is going to appear over here. Okay, so as you can see, I have already defined some of the materials. So if you right click on these, go into properties, you can see the details of the material. You can see the standards that have been used and the database. Furthermore, you can see the material properties of this. Okay. As you can see, I have also defined the time-dependent effects. So again, you can just right-click, go on properties, and you can see these. Okay, let's close that down. And finally, I have defined the tendon property as well. Again, you can check these by looking at the properties. Okay, so I'm going to close that down. As the next step, I will define the sections. So I will be creating one composite section from scratch. For this, I will be using from Tools the section property calculator. So the following window pops up. Here you can go on the settings and you can choose the unit systems that you want to work with and just hit OK. First, I will be creating two materials. So from model, material, add, and just input the information of the materials. Okay. e to -5, and just repeat, press apply, and you can repeat this for the second material and press OK. Now I can create the section. So for that I'm going to go to Model, Section, Composite Section, and Quick Generation. And in this window I can import from the our database. So going to the files, Midas Civil. In here you can see that we have an extensive database of standard sections. So from here I can choose, let's say, SY1. On the left hand side you can see a diagram which explains all the components. So for now I'm going to specify H1, which is the depth of the slab, as 225 mils. H2 is accounting for the curb. B1 will be the width on one side, and B2 will be the width of the slab on the other side. Okay, and now just define the materials, and I'm ready to export. Okay, so I can save this now as any name, let's say main deck, and let me save it into here. Okay, now moving back to Midas Civil itself, I can just go on to Properties, Section Properties, Add, and Composite. From the Composite General Section type I can import this, so I can just click on it and open. Okay, as you can see, the section has been imported to main Midas. Here you can see the section properties on the right hand side. And you can also define the web thickness for shear, so let's say 0.2 meters, and furthermore you can specify the offset of the element. So in this case I'm going to choose center top. Okay, press OK, add in a name, main deck, and press OK. In order to save time, I'm going to bring in the other section properties from a previous project. This is one of the very useful features which you can use extensively. For example, if you have created these sections in a previous project, you can just bring those into your current one and just press OK. And as you can see, all these section properties have been brought in and they have appeared in the works tree as well. Okay, so now that we have all of our sections, you can just right click on these again and go into properties, and you can see the section properties. Okay, I can close this down and I will start the modeling now. So first I'm going to create just one node in the origin. So for that I'm going to click on create nodes, apply. As you can see, a node has been created in the origin. From the top view I'm going to go on to select single and select this node. In order to create the first girder, I'm going to use the extrude option. So extrude, I'm going to extrude a node into a line element and change the material to girder, and then simply define the parameters and press apply. Okay, go to top view again, and as you can see, the first girder has been created. By holding the control button and the scroll on your mouse, you can rotate this. Okay, so in order to create the rest of the deck, I'm going to copy this girder 19 times in the Y direction. So let me take off the perspective view first, select this girder, and go into translate. I will be copying this in the Y direction and by 19 times, and just simply press apply. As you can see, all these have been created. In order to create the two edge beams, I'm going to select the two ends of the deck and just copy these by 0.5 meters and simply press apply, and as you can see, this has been created. I will repeat the same procedure on the other side and press apply. Okay, looking at the perspective view, and from the right view, you can see that all the sections are the same. So now I'm going to assign the appropriate sections. So I'm going to close that down and go on to the wireframe view again, and just simply from the right view, I'm going to select the nodes on the left hand side. When selecting these, you can see that all the nodes and the elements have been selected as well. Okay, and now just simply drag and drop edge beam left. And if you go on to the perspective view, you can see that this has been changed. Okay, so now I'm going to repeat the same procedure for the rest of the girders. So this will be left side, and this will be right side, and finally edge beams on the right. Okay, so going on to the perspective view now, you can see how all these sections have changed. Okay, I'm gonna go to the top view now, and in order to create the pier table, I'm going to first create all the transverse beams and then assign the section property at midspan. Okay, so I'm going to take off the perspective view and create one line element, and the material of this will be transverse and the section as well. Okay, now I'm going to connect the two edge nodes, and as you can see, the element has been created. Next, I will be selecting this and I will be copying it. So again, I'm going to use the translate function. By clicking on the equal distance window, I can click onto the distance between two nodes, and the software automatically defines this distance. Therefore, you can use this whenever you don't know how far these nodes are from each other. Okay, so I'm going to copy this 60 times and just simply press apply. Okay, now in order to create the pier table, I will search for the middle part of the deck, which you can see is at this point. At the bottom of the screen, you can see the coordinates of the node. So by simply hovering over the node, you can see the coordinates. Also, these appear right next to your mouse as well. Okay, so now I will be selecting all these elements here, and I will be activating only these ones. By activating a certain set of elements, that means that you can only do changes to these ones. So activate these. As you can see, the rest of the elements have disappeared. Now looking at the right view and perspective view, you can see that this has no thickness at the moment. So I'm going to select all these elements and simply drag and drop pier table onto this. Okay, now I will be creating the tapering. So for that, I will be selecting all the beams that will be tapered and just simply drag and drop taper left. And we'll repeat the same procedure on the right hand side, which will be taper right. In order to create a smooth tapering, I will create taper groups. So for that, from properties, taper group, I will simply use the select single tool, select these elements and just add a name in, say left, and by pressing add, you can see that this has been tapered. You can also create different types of tapering, such as polynomial, and this can be created in both in the z-axis and the y-axis. Although for simplicity, today I'm just going to use linear ones, and this will be right. And press add, and as you can see, the tapering has been carried out. Next, I will be copying two nodes, which later on I will be using in order to extrude them and create the piers. So I will be copying these nodes to the bottom fiber of the beam. So for that, I'm going to go onto node element, translate, and I will be copying it by minus 3.5 meters. Press apply, and as you can see, these have appeared at the bottom. Next, I will be selecting these two nodes, and as I have mentioned previously, I will be extruding these in order to create the piers. So extrude, I will be extruding node element into line, select the material, which is concrete, and just simply select the pier as well. And also input the parameters by how much you're going to extrude, and press apply. Okay, now again, by rotating this, you can see that this has been created. Okay, and by using the scroll button on your mouse, you can zoom in or out. Next, I will activate the entire model, and I'm going to specify the abutment. So for that, I'm going to go on the top view and take off the perspective view. By selecting the edge elements, so the ones on the far left and far right, I will be extruding these. So I'm going to go on to extrude, and I will be extruding line elements into planar elements. As you can see, the software has specified the thickness, which we have already created in the workstream, as you can see it over there. Okay, and now I'm going to extrude these by 3 meters. Press apply, and as you can see, when you rotate it, the abutment has been created. Next, I will be creating the piles. So I'm going to go onto the right view. I'm going to select certain nodes, and I will be extruding these. Okay, so just select these nodes. Now I'm going to extrude nodes into line elements. As you can see, both the extrude and the translate options are very useful and aid you in the modeling process. Now, by pressing apply, you can see that the piles have been created. Let me zoom out a bit. Okay, and by going on to the perspective view, you can see your entire bridge has been created. Okay, so next I will move on to my next file. I have created different files in order to save some time. So in this file, I have the exact same model, except that I have created some groups. So these groups, as you can see, are the structure groups, boundary, and load groups. And within the structure group, I have assigned elements to certain groups. Okay. Also, on the left-hand side, you can see that I have created some static load cases. These are for self-weight, wet concrete, surfacing, pretension, earth pressure, and temperature. Okay, so next I will be creating the boundaries. So for that, I'm going to activate the deck, left edge beams, and the right edge beams. So let me just activate these. Go into the top view, and now I'm going to be creating the pins. So pins will be created on the left hand side, on the right hand side, and in the middle. Okay, so in order to create these pins, let me unselect these elements. In order to create these pins, I will assign beam and releases to these elements. So now I'm going to select the element at the midspan. So again, search for the midspan and just simply select these elements. Also in Midas, you can use shortcuts. So the shortcut for the select single tool is Ctrl-Shift-S, which is very useful when you're carrying out the modeling. Okay, so now that these elements have been selected, I'm just going to boundary, beam and releases. I'm going to assign these to a group, which is the beam and release group, as you can see it over there. And I will be releasing these on the I node. I'm going to release it for the MY and MZ. So the I node will be on the left hand side of these elements. Okay, so just simply press apply, and as you can see on the left hand side, little green circles have been created. Okay, so next I'm going to repeat the same procedure for the other side, with the exception that for these ones I'm going to release it for the J node. Okay, and simply press apply, and as you can see, all the beam and releases have been applied. Next, I'm going to activate everything, and I'm going to create the rigid links and the pier supports. So for this I will be simply selecting the midspan and activate this. Okay, so looking from the right view, you can see that this is only the pier table and the two piers. So first I'm going to create the supports for the piers. So I'm going to I've just selected the two nodes at the bottom of these, go on to define supports, assign these to the appropriate group, so pier supports, and restrain these in all direction. So it's a fixed support. Press apply, and as you can see, these have been created. Next, I will be creating rigid links between these two nodes and these two nodes. The reason why I'm creating these rigid links is to represent the stiffness between these two nodes, which is basically the depth of the beam. Okay, so now I'm just going to go to rigid link, select the group, so rigid link, select the master node, define the type, that's rigid body, and simply select the two nodes between which I'm going to have the rigid links. And by pressing apply, you can see that this has been created. I'm going to repeat the same procedure on the other side, so just select the master node and select the nodes. Press apply, and as you can see, this has been created. Okay, next I'm going to activate everything, and from the isometric view, let me close this down. I'm going to select all the piles. Now I'm going to create the pile spring supports. These supports are going to account for the soil structure interaction. So in order to do this, I'm going to go into Integral Bridge, select the group name, which is pile spring supports, and select pile springs. As you can see it on the figure as well, the software is going to generate pile springs which represent the horizontal and vertical restrictions of the node. Okay, so simply I'm going to specify the pile spring data now. Let's say stiff clay, the ground level will be at 3 meters, so just simply click at the top of the piles. The diameter of the pile is 0.8 meters, and the subgrade coefficient is 80,000 and CU is 100. Okay, so by simply pressing apply, all these have been created for us. Now if I close this down and go on to the initial view, by double clicking on pile spring supports, you can see that all these nodes have been highlighted, and also from the in the worktree on the left hand side, you can see that the software has created linear and multilinear supports. By double clicking on any of these, you can see the groups of nodes to which these have been assigned. Okay, so that was for the boundaries. Let's move on to loads. First, I'm going to start with the self-weight. So for that, just simply select the load case name as self-weight and the direction into which the weight is going to act, which is the Z. And simply press add. As you can see, this has been created. Now I can close that down, and I will be defining the wet concrete and the surfacing next. So for that, I'm just going to highlight the main deck and activate this. Go into the top view, and again, if I just double click on main deck, this will get highlighted, and I will be applying beam element loads. So I'm going to specify the load case name and the load group name, both as wet concrete. The loading type will be uniform loads, and it will be acting in the Z direction. Okay, and the value will be minus 8 kilonewtons. So simply press apply, and by rotating the model, you can see that this has been applied. Okay, now I'm going to repeat the same procedure for the surfacing. So for that, I can just click on select previous. As you can see, everything has been selected, and just select surfacing for both load case name and load group name. Again, just change the loading and press apply. And as you can see, this has been created. Okay, next I will activate everything. And let me close that down. So for the temperature loading, I will be selecting the deck, both edge beams and the transverse moving loads. Actually, let me undisplay those loadings. Okay, so now you can see that all the elements that have been selected, and I will be applying the element temperature loads onto these. So for this, I'm going to go into temperature and prestress, element temperature load. And here, just simply select the load case name and load group name, temperature load, and apply 15 Celsius. Press apply, and as you can see, this has been created. Now I'm going to go into initial view again and apply the earth pressure. So for that, I'm going to simply select all the plates and activate these. Now I'm going to select the plates on the left hand side, go on the static loads, hydrostatic pressure. Again, just simply select the load case name and the load group name as earth pressure, and then specify the reference level, which is at the top of the abutment, and just input your values. Press apply, and as you can see, this has been created. Next, I'm going to repeat the same procedure on the right hand side, except that the loading is going to act in the opposite direction in this case. Press apply. As you can see, this has been created. Okay, so again, looking at the initial view and activating the entire model, now I'm going to create the pretensioning. So for that, I'm first going to create the tendons. So I'm going to go into structure and tendon template. Because we have identical sections for main deck 1 to main deck 18, I can create a temporary group and just assign all these groups to that. Okay, so assign elements, and here I can just simply click on these and assign them. As you can see, in the meanwhile, when you double click on the group, the elements get highlighted and you can see which elements you're adding into the temporary group. Okay, 12, 13. Okay, and the last one. By pressing OK, you can see that all these elements have been added in, all the sections, and we can auto-generate the tendon template for these. Press OK, and as you can see, the tendon template has been generated. As we don't need all these tendons, I'm just going to simply delete some of these. Obviously, this depends on your project, but for simplicity now, I'm just going to delete it this way, and by pressing apply, all these tendons will be created. Now I can just select these ones and delete, and I can repeat the same procedure for the left hand side and the right hand side. So go into auto generation. I'm just going to select the type and the name, press OK. Again, we don't need all these tendons, so we can just delete them. You can also zoom in, and you can delete any of these tendons which you don't need anymore. Okay, so let's say delete all these. Okay, so again, press apply, and I can delete these. And the same procedure can be repeated for the right hand side. Select the type, name, press OK, and again choose the tendons that you would like to delete and just press delete. Okay, so let's just say OK, and now going on to the display, I can display all the tendon profile points, press OK, and as you can see from the right view, you can see all the tendon profiles and the parts that have been deleted. Okay, so now that we have these tendons, we can just apply the loadings onto them. So go on to load, prestress, tendon prestress, and just simply select the load case name and load group name as pretension. Next I'm going to select all the elements and just apply a stress to both ends. And another advantage of Midas Civil is that you can choose your units whenever you want, so you can just change them at your convenience. So now I'll just apply 1200 megapascals and press add. Okay, by closing this window down and going on to the static load, you can see that these have been created. Okay, so let me undisplay these tendons by going on to the initial view. Next I will be creating the moving load. So for that I will go into moving load. The moving load code will be Eurocode. In order to save time, I'm going to specify an entire lane and a vehicle, and I will specify the rest. I will show you the rest in my next file, in which I have already predefined all the lanes, vehicles and load cases. So simply just press add, and in the line name just define the name. Again, I can just change the units because millimeters are a bit inconvenient. Okay, so here you can just simply input your details for the lane. This will be applied onto the cross beams. So for this I have created the transverse for moving load, and now let me just select the tag and activate this. And now I can just simply click on the 2 points in order to define a line from which the eccentricity will be measured. Okay, so by pressing OK, let's go into the top view and you can see that the first lane has been defined. Next I'm going to specify a vehicle. So as you can see, we can specify both standard and user defined vehicles. Now I'm going to add a standard one. In this section we have a variety of database, as you can see over here, and also for vehicle loads we have LM1 to 4. So let's see LM1. Here just you can simply input your adjustment factors and press OK. Okay, so now when scrolling down in the worktree, you can see that both of the predefined the lane and the vehicle is still blue. The reason for this is because the moving load cases have not been defined, therefore these are not connected. And this is what I'm going to show you in my next file. So just if I open this up, as I mentioned previously, I have specified the line lanes, so let me display this. Again, everything you can just display by right click and display. Okay, so as you can see, I have the 2 sidewalks, the 2 remaining areas and the 4 lanes. Also for vehicles, I have specified a UDL for the footway, LM1, and again if you just double click you can see the third one is LM3 with an SV100. Okay, and in order to connect these I have created the moving load cases, so GR1 and 5. Again you can just double click on these and they will open up. So all I had to do is define the load model, whether if I want to ignore the psi factor or not, and define the load case data for vehicle and footway. Finally, you can just assign the lanes. Obviously, the lanes go into the lanes window and footways into the footway, remaining area. Okay, cancel that out. And similarly for moving load case 2, with the exception that this is a straddling one. And as you can see over here, you can define which lanes are straddling. Okay, so now that our moving loads have been defined, I'm going to specify the construction stages and the composite stages for construction stage. Okay, so this can be done by clicking on this little icon over here, or if you go on to load, construction stage, define construction stage. Here by pressing add, you can see the following window pop up, and simply input the name, define the duration. In the first construction stage we will have only the substructure. This will be activated at an age of 28 days. Apply. For boundaries we will have the pier supports, the rigid links and the power spring supports. And for loads we will have the self-weight and the earth pressure. Okay, so simply pressing apply, your first construction stage has been defined. Now I can move on to the second one. In this stage we will have the main deck. So again, this will be activated at 28 days. Add. The boundary will be beam edge releases. The reason why I'm adding in the beam edge releases now is because at this point the girders are only simply supported on the abutment or the pier table. These will be fixed or integral as soon as the composite action kicks in. Okay, so finally for loading we have the wet concrete and the pretension. Okay, and now press apply. We can move on to construction stage 3. This will be a long one, so the duration will be 10,000 days. The elements, now we will activate the left and right edge beams and also the transverse ones. Okay, again these will be activated at 28 days. Add. The boundaries in this stage are, we're going to remove the beam edge releases because at this stage the slab, which has been cast in the second stage, now it has gained strength. So now the girders are fully fixed. And for loadings we will have the wet concrete removed and we will have the surfacing. Now in order to account for the surfacing, I'm going to create an additional step which is at 21 days. Simply press add, and I'm going to save the results for the additional step. So go on to surfacing now and just select 21 days and add. And as you can see, by pressing OK, all these construction stages have been defined for you. Next, I'm going to define the composite section for construction stage. Add. The activation stage is the second one. As you can see in the background, the main girder has been highlighted, and now we have to specify the construction sequence. So the first material will be the girder. This will be activated in the second stage and the age will be at 28 days. The second material will be the slab. This will be activated in the third stage and at 7 days. Okay, so in the similar manner it can be defined for both the right hand side and for the left hand side, although in order to save time I'll just move on to my final file. In this one I have defined these composite construction stages, so let me show you that. Okay, as you can see here, for the left side and for the right side, if you double click on them, again the software is going to highlight this, and also you can see the construction sequence, which is the exact same as for the main girder. Okay, so let's look at the results now. Let me close these down. So let's start with the deformation. One of the great advantages of Midas Civil is that you can check your results for any construction stage as well as for the post-construction. So let's see in construction stage 1. Let's look at the summation. So just simply press legend and deformed shape. As you can see, this is the deformed shape in millimeters. Okay, so let's see for stage 2. And also you can, let's check it for the post-construction stage as well. Okay, and as you can see, the displacement is quite small due to temperature. Okay, so let's move on to forces. For beam forces and moment, we can check it again in each construction stage. Let's say for stage 1. As you can see, these are the beam forces for stage 1. We can check it for stage 2 again. And also for stage 3. Okay, let me put on the legend, apply. And on the right hand side you can see the moment. Again, if you wish, you can change the units and you can see it in kilonewtons meter. Okay, so let's see it for post-construction. And here, as you can see, we have a variety of load cases. You can check it for each of these. And obviously you can change the components as well, so if you want to see the moment in any other direction or the forces. Okay, so let's move on to stresses. So for beam stresses, again, these can be checked in each construction stage. Although now let me activate the entire model. So let me go to post-construction stage, and here I'm going to activate this load group. Simply activate this, and as you can see, the beam stresses for this. Also, as you can see, we have you can check it for different components, part 1 and part 2, and also for components that are causing this, for axial and bending. Okay, so moving on to the moving load tracer. Beam forces and moment. Let's go back to initial view and activate the entire model. So beam forces and moment, and here you can just input the key element, and the software is going to generate you the most severe live loading. Okay, so as you can see over here, let me take off the values so it's more clear. Okay, so you can zoom in and you can see the influence lines and the live loads. Okay. Also, if you would like to see the coexisting forces for this element, you can simply turn this into a static load and you can check these. Okay, and finally let's have a look at the results tables. So let's check for the tendon stress losses. Another advantage of Midas Civil is that you can check the tendon stress loss broken down into components, so like creep and shrinkage, relaxation, and so on and so forth, and you can check it for each of the strands that you have and each construction stage. Simply press apply and you can check the results. Also, all of our tables are fully Excel compatible, so you can simply export these into Excel. Furthermore, we can check the tendon time dependent loss graph as well. So again, you can just choose the strand which you're interested in and the construction stage. Okay, so let's close that down. Moving on to the PSC. So here, let me move back to initial view. Here, as you can see, we can choose the code which will be used. Also, the design parameters can be defined. So for that, just click on parameters. Here you can choose the design code, the national annex. As you can see, we have British and Italian as well. Also, you can define the strut angle and which ULS and SLS parameters you would be interested in. You can select all of them and just click OK, and this will be done. Okay, so next I'm going to move on to the design data. So design material, as you can see here, you can define the concrete material section for both the girder and the slab, and the same applies for the rebars as well. As you can see, we have extensive database of codes, and you can select all the grades as you wish. Furthermore, you can do the same for the rebars, and in accordance with your project, you can select their class as well. Okay, so next, design output and position. This is a very useful feature for all projects, especially larger ones. When you know that elements in certain position will be in more critical condition, then you can just carry out the design for these ones. So basically what you do is you can just select certain elements. Let's say go on the top view, and I'm going to select the deck and activate this. Okay, so let's take off the Y view. So I can just select these elements and hit apply, and these are going. The design will be carried out only for those ones. I have already predefined the elements, and these can be seen in the. If you click on the three dots, as you can see, I have all the elements from 541 to 600, which basically is the mid girder. Okay. And the same applies for the output position. You can simply select certain elements, and the software is going to generate you an extensive Excel report. Let me show you the report. So as you can see it over here, the report has been generated for element 541 and for position I. In this report you can see all the design conditions with details. Also, you can see the Eurocode and the clause onto which this was based on. You can also see the tendon profile, the tendon profile information over here, the ultimate moment resistance, and the calculations as well. Furthermore, the checks are shown as well. If they pass, it shows OK. If they don't pass, then the software is going to highlight this in red. Okay, so moving back to the model again, in order to create the serviceability load combinations, we first need to create the load combinations. So for that, I'm going to go into Result, Load Combinations. I have already predefined these in concrete design. You can do this either manually, or you can use the auto generation. So here, just simply select the code that you've been interested in, for example Eurocode. You can select the construction stage load cases, the load factors, leading variables, and also the assessment of groups of traffic loads. For example, in my case, I have GR5 as a frequent value. Okay, so if I close these down, in PSC, you can see that I have used these load combinations for quasi-permanent, frequent, and the characteristic combinations. Okay, so close this down. Finally, I have also defined the shear connectors. So these are smooth. You can input the angle, also the area, and the strength of your steel. And by pressing apply, this will be applied to your design. Okay, so let me close this down. All these informations are used in order to create the results. The results are shown here in table format, although instead of showing you further tables, I'm just going to show you the PSC result diagram. So let me first activate the entire bridge and go onto the front view, and in the results diagram you can see the forces, and let's see in a solid fill. Okay, so as you can see over here, the barred section is the resistance of the members, and the filled section is the design force. Okay, you can also check this for stresses. So go on to stress. you can choose the components which you would be interested in and simply hit apply, and as you can see, the stresses are shown over here. Okay, so let me close that down. And finally, moving on to the design of piers, I'm going to change the view and go to the initial view. First, I'm going to select the piers because I'm going to do the design for these, and go on to RC design. Here, first we need to define the column section data for checking. So by double clicking on piers, you can see that I have already predefined the information. I have defined the type of hoop rebar, the spiral size, the spiral space, and the number, and also the rebar data, the number of rebars and their sizes, also the cover as 50 millimeters. Okay, so if I close it down, next I'm going to carry out the concrete code check. So for columns, there you go, and here if I click on the two arrows, you can see that the section is suitable. Also, you can go on to the members and you can see all the members over here. You can click on any of them, go on graphic, and the following window pops up. Here you can check the design conditions, the applied loads, axial forces and moment resistance checks, the PM interaction diagram, shear force resistance checks, and the stress checks as well. As you can see, these are all suitable. Okay, you can also check the detailed calculations. So in this one, the software is specifying you all the load combinations for which the checks have been carried out, and as you can see, it specifies the data for column checking and does the calculations as well. So over here, the checks for slenderness and biaxial loading, and so on and so forth. You can check everything in this document. Okay, so I can close that down. No. And finally, you can check the PM curve as well. And this is a dynamic curve, so you can just move it around. And on the right hand side, you can see the results. Okay, so this is the end of my presentation. If you have any questions, you can put these down into the chat box, and we will reply to these as soon as possible. And if you have any further questions, you can also send these to uksupport.midasuser.com. Thank you.